In this video, we're going to go through molarity calculations. The essential question that we're going to be answering is how can molarity be used to determine the concentration, volume, or amount of solute in a solution? So naturally, let's start with what is molarity? Well, molarity expresses the concentration of a solution. And we measure molarity by calculating the moles of solutes over the liters of solution. So the more solid we dissolve into our solution, the higher the concentration, the higher the molarity. Molarity is just the chemistry word that we use to describe concentration. Now, really important, your volume has to be in liters. It cannot be in milliliters. So if you get a question where you're given units of milliliters, you do need to convert it into liters. Using the conversion, 1 liter is equal to 1,000 milliliters. All right, so let's dive right in. So our first question says, what is the molarity of a 5-liter solution containing 2 moles of glucose? And again, our equation is molarity is equal to moles over liters. So we have 2 moles over 5 liters. So I would just type into my calculator 2 divided by 5, and I would get 0.4. Now the units for molarity are just capital M. Okay, and the correct way to read this would just be 0.4 molar. So the units are just molar for molarity. Okay, here's the next one. Calculate the number of moles of sodium chloride in 370 milliliters of a 2.5 molar solution. All right, so here we're given milliliters, and we need to convert those. So I have 370 milliliters, and I know there are 1,000 milliliters in 1 liter. So when I plug this into my calculator, I'm going to get 0.37 liters. You can also just move the decimal place 3 places to the left. So if I did that, 1, 2, 3, I would end up at the same place. So either way is fine. Okay, so here we're trying to find the number of moles. And if I wanted to get moles by itself, I would multiply both sides of my equation by liters. So to calculate the number of moles, I'm just going to do liters times molarity. So I have 0.37 liters, and then my molarity is 2.5 molar. So let's plug that into our calculator. So we have 0.37 times 2.5. And of course we want to round this appropriately. So it looks like we have 2 significant figures. So I would round that to 0.93 moles of sodium chloride. Okay, next. How many liters of a 0.75 molar solution can be made from 1.3 moles of iron chloride? Okay, so here we're solving for liters. So let me write my equation again. Okay, so if I wanted to get liters by itself, I would first multiply both sides by liters, cancel these, and then I would need to divide both sides by molarity to get liters by itself. So a really quick way to do the algebra here is just to trade places. So if you do have to find liters, the molarity and liters can just trade places. Or if you want to go through and do 2 algebraic steps, you'll get the same answer. But an easy way to remember is just swap molarity and liters. Okay, so we're trying to find liters. So I'm going to do moles over molarity. So I have 1.3 moles, and my molarity is 0.75. So if I plug this into my calculator, I got 1.3 divided by 0.75. I get 1.733, and of course we want 2 sig figs, so 1.7 liters would be my answer here. All right, let's move on to using molarity in dimensional analysis. So we're going to be doing some multi-step problems, and we can use molarity as a conversion factor. You never, ever, ever start with molarity. So don't do it. Don't be that person that starts with molarity. You're either going to be starting with volume, mass, or suppose you could start with moles, but you'll never, ever start with molarity. You're going to probably start with molarity. Don't do it. Okay, so if I have something that is 1.5 molar, I can rewrite that as 1.5 moles over 1 liter. So anytime you have molarity and you need to convert, you want to just rewrite it as moles over liters. So it'll always be whatever the number is. In this case, it's 1.5. It'll be that many moles over 1 liter. So let's look at an example. It says, how many grams of sodium chloride are needed to make 0.43 liters of a 2.7 molar solution? So we're going to start with molarity. No, we're not! Don't do it! Never start with molarity. Always start with your liters or your grams. Sorry to come at you like that, but I don't want you to forget. So let's start with 0.43 liters. And we want to turn this into grams. We don't have a way really to go from liters to grams, but we do know how to go from liters to moles using, you guessed it, our molarity equation. So if I set this up, I know that it's 2.7 molar, so that means in 1 liter I have 2.7 moles. And now I can go to grams. For every 1 mole, I happen to know that sodium chloride's molar mass is 58.44 grams. That's how many grams are in 1 mole. Okay. So when I go to plug this into my calculator, I'm going to do 0.43 times 2.7, and then I'm going to multiply that by 58.44. Okay, and again, we want 2 sig figs here, so it looks like it's going to round to 68 grams. Okay. So I think in a previous video I mentioned the only time that you're going to have something other than 1 mole is when you're doing a mole ratio. That's not true now because we know we can use our molarity as a conversion factor. So that is another time where it will not be 1 moles to a gram or Avogadro's number. It's going to be when you're using the molarity. All right, let's keep going through a couple more of these. Number 5 says, how many grams of sodium hydroxide are needed to make 750 milliliters of a 1.5 molar solution? You're probably thinking, let's start with the molarity. You would be wrong. We're going to start with our milliliters. But we need to convert it to liters first. So watch this. 750 milliliters. We need to convert that to liters. There are 1,000 milliliters in 1 liter. Now, going from liters to moles, and then from moles to grams, just like in the previous problem, if it's 1.5 molar, that means in 1 liter, I have 1.5 moles. Now I can go from moles to grams. For every 1 mole, sodium hydroxide's molar mass is 40 grams. Okay, so let's plug this into our calculator. So you can do the conversion to liters separately, or you could do it together with the problem like I just did. It makes it a little bit easier, saves you a little bit of trouble having to rewrite everything. So I get 45 as my answer here, and it looks like 45 works perfectly because we have 2 sig figs. let's move on to number 6. Okay, so number 6 says, determine the molarity of a 0.25 liter solution containing 4.5 grams of copper chloride. Okay, so here we have liters and grams. So what are we going to do? Well, we're trying to find molarity, and remember, molarity is moles over liters. So we already have our liters, we just need to find our moles. So let's take our 4.5 grams and let's turn that into moles. So 4.5 grams, it's copper chloride. So copper chloride, it's 134.45 grams. That's how many grams are in 1 mole of copper chloride. So if I do the math here, I get 0.033 moles. Now, it's just a matter of plugging in the moles I just found and the liters given in the question to find my molarity. So I have 0.033 moles over 0.25 liters. Let's go ahead and plug this into our calculator. So 0.033 divided by 0.25, 1.32. We want to round that to 2 significant figures, so 0.13 molar would be my answer. All right. I don't know about you, but this is so much fun. All right. How many liters of a 2.5 molar solution can be made from 4 grams of copper chloride? So we're going to do the same thing. We need to convert to moles first, and then we're going to take our moles and convert it into liters. So very similar to the last one, we're going to do this as one continuous calculation this time. So let's start with our 4 grams of calcium chloride. We need to turn that into moles. So molar mass is 110.98 grams. That's how many grams are in 1 mole. And we know that it's a 2.5 molar solution. So for every 2.5 moles, that's how many moles are going to be in 1 liter. So again, your molarity equation doesn't always have to be moles over liters. In this case, we flipped it because we were trying to find liters. Okay, so 4.0 divided by 110.98, and let's divide that by 2.5. So we get 0.014. We want 2 significant figures, so it would be 0.014. And it's asking us for liters, so those would be our units there. All right, uno más. How many milliliters of a 0.75 molar solution can be made from 6 grams of lithium hydroxide? Okay, so don't start with molarity, start with grams. Okay, so we have 6 grams. We need to turn it into moles. Then we need to use our molarity to get liters. And then we need to convert our liters into milliliters. So converting this into moles, it's 23.95 grams in 1 mole. Our molarity is 0.75, so that means there's 0.75 moles in 1 liter. And since the question's asking for milliliters, for every 1 liter, there's 1,000 milliliters. Anybody want a dog? All right. So we have 6 divided by 23.95 divided by 0.75. And then to get it from liters into milliliters times 1,000, it's like 334. We want 2 sig figs, so let's call that 330 milliliters. Okay. That is how to do molarity calculations.